Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the disk information commands and how they can be used. When you are writing applications, you will find yourself either reading from or writing to disk drives. As disk drives can vary in capacity, there will be times when there is not enough space left on the selected disk drive. If your application is attempting to write to this location, it may well fail because there is not enough room to save your file. To cater for this eventuality, you will have to put error handling within your code to determine if the attempt to write to a disk location has failed. One thing you can do to preempt this is to test the destination location prior to saving your file, to see if that destination location does indeed have enough disk space to take the file you're about to give it. We can perform this action quite easily by using two of the inbuilt PowerBasic commands. Let's have a look at the code. We're going to create two local variables. One in which we're going to store the number of bytes that are available on our selected drive, and a second which is going to contain the location that we wish to save to. The QBytes variable is defined as a quad. This is effectively a very big long. Because disk drives can now be quite large, we'll need this to store the number of bytes we have on it, both the number of bytes in total and the number of bytes free. So first we will define our C drive. This is a drive we want to test to see how big the drive is. To do this, we're going to use the inbuilt command disk size. This will return in bytes the size of our selected drive. Because it's returning in bytes, we may want to actually adjust this to bring it either into kilobytes, megabytes or gigabytes. We can convert this by just dividing the value that comes back by a number. If we divide by 1024, we'll get the value in kilobytes. If we divide that by a further 1024, we'll get it in megabytes, and again we can get it in gigabytes. We can quite easily perform this as one line of code. This will return the number of gigabytes that this drive has as its full capacity. We can then print this out to our log. We're using the format $command to turn the QBytes variable back into a string, and we're giving it a mask, which is the hash, comma, and 3 hashes, to say that we want it displayed as a number with a delimiter of a column in thousands. So if we try running that now, we'll see it's reporting that the C drive is 118 gigabytes in size. So that lets us see the total capacity of the C drive. How can we tell how much disk space is actually free for our use? Well, the second command is a command called disk free, and this works in exactly the same way. It takes a single parameter, which is the drive we are interested in, and if we divide that by our numbers again, we'll get the value in gigabytes. And we can report that to our log in the same fashion. So we now know that our C drive has currently 53 gigabytes free. Using this disk free command before you attempt to save a file to a location will enable you to know that there is enough space to save the file. However, these commands go slightly further than just your local machine. What happens if you're saving to a network drive? If we have another machine, perhaps a NAS, which has a folder into which we wish to save. If we save our str drive variable to contain a URL, in this case it's going to look at the disk 001 computer and its shared folder backups. If we run that now, we will see that the disk 001 backups currently is an 8 terabyte drive, of which it has almost 7.5 terabytes free. So you can use these two commands to determine the capacity and free space on any drive in your system. And if you have a network drive to which you have access, you can determine how much space is left on those as well. We're now going to make use of a couple of functions within one of our libraries, the drive info library. If we add that to the list of encode files at the beginning of the application, we can have a look to see what this is going to do. There are two functions within this library, the getDriveSize and the getDriveType. If we change our drive selection to the H drive and run our application now, we can see we've got 116 gigabytes in total on that drive and 107 gigabytes free. Although this tells us how much capacity and how much free space we have on that drive, we don't know what kind of drive that actually is. We can use the getDriveType function, which takes a single parameter, being the drive we are interested in, and this will tell us what type of drive this actually is. If we run that now, it tells us this is a removable disk. If we change our code back to the network drive, it will report that this is indeed a remote network drive. And if we change it back to our C drive, this is reporting that this is indeed a fixed drive. The second function within our library is the getDriveSize. This will return the size of each drive specified in our system. This takes no parameters because its task is to work out what drives are available and display them. If we run this now, it will tell us all the drives we actually have and how much space is actually set as their capacity. It's reporting both an I and a J drive in the system with zero capacity. These are removable drives which I had in the system a few moments ago and have since removed. So this is a very easy way of determining what drives are available on any system. Hopefully you'll find these two inbuilt PowerBasic commands and the two additional functions useful in your applications. However, that's it for today. Thank you for watching.